In this video, we'll be looking at how to deal with missing values, also known as INAs. For this video, we're going to be using the melbdata.csv file, which there'll be a link to that and this R script with all the code in it in the description. So the first thing we should do is get the melb data into R, which we can do by clicking import dataset from text base, and then we will go and find wherever you have it on your computer. Mine is in this folder, so I'm going to click open, and I am going to rename this just to house because I feel like it, and it's shorter to type than melb data, and this data is just about a bunch of houses in Melbourne, so house I think is a decent enough name. We do see that heading is not on yes, and you can tell because the names are v1, v2, v3, so we want to make sure that is on yes, and we will click import, and here is our data. You'll notice that I also have this test data set up here. I just made this by throwing in some random numbers and a couple INAs, and I'm just going to use this to demonstrate a couple functions, but overall we'll be looking at the house data set. This is 13,580 rows, so it's kind of large. So the test data set's just a way to look at how certain functions work on, a really small data set. If you want, you can download this test data set with the house one in the same link in the description, but it's not necessary. So one question they ask a lot on homeworks is count the number of INAs in each column. How many missing values are there in each column? Well, the way they teach it is really not very efficient. Basically, the code they give, you have to go through one by one, like one column at a time, and it returns the number one at a time, and it's really long and slow. So the way that I found that does it really, really quickly and easily is using the is.na function with the colSums function. So the really quick, really easy way to do it is with the colSums function and the is.na function. So our final code is going to look like this, and don't worry, I'm going to break it down. But you see if we run this, what it returns is each of the columns in our data set. You see these are just each of the names, and how many missing values there are in each one. So we see that car has 62 missing values, and in building areas got 6,000, year built's got 5,000, and I bet if we scroll over, yeah, you can see this is what INAs look like in R. So this is actually two functions right here. We have the is.na function on the inside, and then the colSums function on the outside, and this is what programmers call nesting functions. That's not terribly important to know, but I'm just giving you the terminology in case I say it again. So there will be timestamps that you can hover over and skip this part if you don't want to, but to explain why this works, I'm going to use the test data set. So that we have the is.na function on the inside. So what the is.na function does is if you do is.na of a data set, it will return a matrix of the data set where every single value is either false or true. So if there is an INA, and I'll go up here and look at it. So if there's an INA, you can see it's true. And wherever there isn't, it's false. So when we did it for the house data set, it just did this for our enormous data set. There's a false and a true for every single one. And so the other function we use is colSums. So what colSums does, it goes through every single column in a data set and adds them all and returns the sum in each of the columns. Now obviously that's not really going to work on the house one because some of the columns like suburb, address, type, a lot of them are words, and you can't really take the average of words. Well, I say that, but that's actually exactly what we're going to do when we pair it with the is.na. So if we look back down in the console, is.na returns falses and trues for every single thing. Well, in programming, falses are the same thing as 0, and true is the same thing as 1. The computer can read these as just 1s and 0s, even though we see false and true. So if we just add these columns, that's the same thing as just doing, like for instance in B, that'd be 0 plus 1 plus 0 plus 0 plus 0. Or in C, if we do it, it's 0 plus 1 plus 0 plus 0 plus 1. So that would give us 2, which is the number of INAs in C. So basically, adding the columns of falses and trues is the exact same thing as just counting the number of trues, which is counting the number of INAs. So again, if we go back and we do colSums is.na and put the is.na on the inside, if we run that, you'll see it returns the A column has 0 INAs, B has 1, C has 2. So that's why this works. So now another question that gets asked, and I believe this gets asked on the project, is how many incomplete observations are there? Now observations is just another word for rows. You see, if we look up in here, that like house has 13,580 obs, and test has 5 obs. Obs, that's short for observations, and these numbers are just a row numbers. See, 5 obs, 5 rows. You see, the number of incomplete observations isn't just the number, like the total number of missing values. It's like if we look at our test data set, you see we had 1 missing value in B, and we had 2 missing values in C. So if we added those together, we have 3 total missing values. But there's not 3 missing observations. See, there's only 2, because there's only 2 rows that have missing values in them. So the way you can count that number of incomplete observations is you doing something very, very similar. So for the housing data set, the code looks something like this. It's going to be more nested functions. It's going to be the sum of the not, and not is an exclamation mark in programming, which I'll get into in a bit, but it's the not complete cases of house. And if we run that, you'll see that gives us a number 6,750. And that's how many rows have at least 1 missing value in them in the house data set. And again, if we scroll over here, you can see, yeah, a lot of rows do share NAs. So it's a good thing we did this instead of just adding those, because a lot of them do share NAs. So how is this working? Well, this is a very, very similar process. This is 2 functions as well, but now it's complete.cases and sum. So complete.cases, if we're working from the inside out, what that does, and we're going to use the test data set again, it returns true if a row, and I'm going to go back to test data set up here, it returns true if a row has no missing values in it, if it's complete, and it returns a false if it has an NA. Now some of you might already be saying, ah yes, we have trues and falses, so we can add like we did up here, and that'll, count the number of missing rows. That's the general idea. That's what we want to do. Problem is, if we add here, that's counting the number of complete rows. See, this would be 1 plus 0 plus 1 plus 1 plus 0. So that would give us 3 when there's only 2 rows with missing values. So what we want to do is basically flip the trues and falses here. If we can make complete.cases give us false whenever a row is complete and true when it has an NA, then we could add those, and that would just be counting the number of rows, which is what we did up here. So the way you flip it is you just put an exclamation mark in front of complete.cases. So in R, an exclamation mark means not. So if I put an exclamation mark in front of complete.cases, that's saying, give me the not complete cases. So you'll see if I run this, it's the exact same thing, but it flipped the falses and trues. So now we can add those just using sum. And we're using sum and not colSums, because this is just one list of falses and trues. It's not in like a matrix form like this, where you see there's very defined columns. This is just a row of falses and trues. And there's no columns here. So we just use sum to add. And you see if I run this, that gives me 2. So what do we do with NAs? We know how to count how many there are, but what do we do after that? We don't want to leave it alone, because missing values are not good. Missing values will mess up your analysis and all your calculations. You do want to do something about them. And we have 2 main options: omission or imputation. And I'm going to talk through each of them and like the pros and the cons. And I know it might start to seem like I'm just rambling or talking about non-helpful things, but I know that on the project, they tell you to choose between omission and imputation, and they ask you to give the reason why. So I'm going to explain some advantages and disadvantages of both, and also how to program them. But you can skip ahead to just the programming part if you're not interested, but I think it's good to know. Omission is our first one, and that's basically saying if a row has an NA in it, just remove it from the dataset. Just yoink it out. Now some pros to omission: it's really easy to code. It's very, very easy to code. Also, if you have big datasets, like if you have a lot of rows and the number of missing rows is, pretty small relatively, just dropping a couple of rows isn't going to kill you. It's not going to completely ruin your analysis or anything like that. Now, like in House's case, it has almost 7,000 missing rows. Like about half the rows are missing. So it's a bit more debatable in the House case if you'd want to do omission or imputation, which again, we'll get to imputation in a bit. But generally, if you have a bigger data set, it's fine to just, lose a couple rows instead of trying to do imputation. Now, some cons. Well, if you have a small data set like the test one here, if I just remove the rows with missing values, well, I just lost 2/5 of my data. That just was a huge chunk of my data. What if 3 rows were missing? I would lose the majority of my data. So basically, in cases where the number of missing observations is large relative to the size of the data set, omission may not be the best choice. It really just depends on the data, but I do find myself using omission more. And again, like I said before, it's very, very easy to code. What we're going to want to use is a function called na.emit. And what na.emit returns, and I'm going to do this for the test dataset just so it doesn't flood my console, but what na.emit does, it just returns your dataset, but without the rows that have NAs in them. So that's it. It literally just copies your dataset, but gets rid of all the unhelpful rows. So usually when you're cleaning a dataset like this and removing the missing values, you want to put it in a new name so that you can then use that new data set from now on. Because see, I can run na.emit test, and that gives me this in the console. You see, if I go back to test, it did not get rid of them. Because na.emit on its own doesn't just change the original one. Let's say I want to do omission on the house data set. What I could do is something like, let's say house om for omission is equal to, and also you might see me put these arrows. That's the exact same thing as equal to. I'll keep the equal sign here, but there is not a difference. So if you see me type the arrow, don't freak out. It's just the same thing as an equal sign. But I'm going to say that the name, and this is just whatever you want to name your new data set. A lot of people do clean house, or clean whatever the data set original name was. But I'm going to do house om for omission, and let's do na.emit house. And now when I run this, watch this top right panel. When I run this, boom, house OM is up there. If we check, and if we click on it and check, and you can see in building area and year built, there aren't any NAs anymore when there were a lot before. And you can also just see by looking, I didn't even have to open it, because if you look, now it has only 6,830 rows. But yeah, that's how you can do omission. Now imputation. Imputation basically says, instead of getting rid of the entire row, why don't we just replace the NA with something else? A very common thing to do is just replace the NA with the mean of the rest of the column. And it can be anything like the mean or the median. Its biggest pro is that you're not sacrificing, entire rows of your data, which is really good when a lot of your observations have a missing value in them. Which, like in house, we have 21 variables, that's 21 columns. So it really sucks when you have to get rid of an entire row just because one of these had an NA. You're losing a lot of information. So one of the pros of imputation is you don't lose all that. Now the cons, the numbers you sub in, they are not always reflective of the actual data, and they can be quite misleading sometimes and lead you to wrong results. Because, for instance, replacing every missing value with the mean, which is what we're going to do in this case, but replacing every value with the mean does not always, that's not always accurate. For instance, the example I always give when I'm tutoring, because I have this NBA salaries data set. It's just a bunch of basketball player stats. But the example I almost always give goes back to that, where there's a points column for the player's average points per game. Now let's say that one basketball player, out of all the basketball players, let's say one of them had an NA. And so we decided, okay, we're not going to get rid of that row. Let's just plug in the average of the rest of the players' points. Well, that works, and that probably will be accurate for a lot of people. But also, what if that one player was Michael Jordan? Then the average of everybody else's points is that's a huge underestimate. Or what if it wasn't Michael Jordan? What if it was some no-name basketball player who nobody knows? He came in one game and played 5 minutes, scored nothing. The average of everybody's points is going to way overestimate him. And this can lead to problematic things when you're doing, in the future when you're doing regression and trying to predict things. It can mess up your predictions. It also, the programming, it has to be done on a column by column basis. So basically you have to go through each column that has a missing value and replace them one at a time. And there are ways to speed it up. Unfortunately, it's beyond the scope of this class. So yeah, it has its pros and cons. Basically, what it comes down to for me is usually, is the column with a missing value something that could be like, would it be fine if it replaced it with the average? Like, does that make sense? Like, could that work out? Whereas with like NBA player points, it could, but like there's a lot of situations where it wouldn't. Or like I know there's one that comes up, it's like stock price. Could you really just take the average of every stock price and give it to some random company? Would that really work? But yeah, let's actually get into imputation. So before I actually start, what I want to do is make a copy of the original data so that I can perform imputation on it. Because in general, I prefer making copies of my original to experiment on so that I can keep the original, completely as it was. Because if I end up, overwriting the original and then messing something up, well, then I kind of got to start all over, like wipe it off of here and re-import it all back in. And that can just be annoying. So what I like to do is make copies. So here I'm going to do house im for imputation, and I'm just going to say that's equal to house. And see, I just made an exact copy of the data set. I'm just saying that this new name right here, this is equal to the old name as well. I'm going to select all the missing values in one column. I believe I'm going to do the building area column because that had the most NAs. But it really doesn't matter. If you're doing imputation, you'd have to do it for all of them anyway. I'm not going to lie, this is a long line of code, and I'm going to break it down part by part, but it's going to look scary at first. First, what I'm going to do is I'm going to select the column with the missing values that I'm wanting to change. So in this case, I'm going to do house im, and the way we select a column is we do the name of our data set, $, and then the name of our column. So I'm going to do $, and it's building area. So now that we've selected the building area column, I'm using the square brackets because I want to select only the values that are in A. And square brackets, if you haven't seen my video on subsetting, square brackets are how we grab specific values basically that we want from an overall data set, how we select a smaller subset from an overall data set. To grab all the values that are in A, we're going to use two functions. We're going to nest two functions. So we're going to use the which function, and inside the which function, we're going to do is.na, and then we're going to put in the name of our data set. We're doing house im, and we select the same column because we're looking at this one column. We want the missing values in this column, and that's it. If I run this right now, you'll see it just prints a crap ton of NAs because there was 6,750 of them. It can't even print all of them. But you see, this grabbed all the NAs. And don't worry, I'm going to walk through it again part by part. But if we want to replace all these NAs with something else, and in this case we're going to do the mean, well, I'm going to say all these NAs are going to be equal to the mean of the column. And again, to select the column, I do the name of the data set, $, and then the name of the variable. Now, this is not going to work if I run it. Because see, if I just run the mean part, you'll see it gives me an A. That's because I haven't updated it yet. There are still NAs. And when the mean, which is just adding all the numbers and dividing by the total, when it sees an NA, it freaks out and doesn't know what to do. Fortunately, we can fix that. Mean has an optional argument, which is just an argument, something we can add on to the end that will say, if you see an NA, ignore it. So the way we add this is we put a comma, and commas are always how we separate arguments inside a function. We're going to do na dot, and you'll see it starts to autofill, na.rm equals, and we want this to be equal to true. And true you can write either as a capital T, and you see like it turns orange. That's how you know, like see if it was a lowercase t, it'd be white. If it turns orange, that's meaning true. Also, you could type true in all capitals. Either one works. I just do T because it's shorter. And if you're wanting to type false, you could do F or false. But in this case, we're wanting to set na.rm to true. And you see if we run it now, just this part, that gives us 152 about. We have this whole thing, which gives us all these NAs, and we're saying all these NAs are equal to this thing, which we see is 151.9676. So if I run this, you'll see this line pop up, but I mean, you didn't really see any, big change. But if we go to house im, and we scroll to building area, you'll see there are no more NAs in it. Instead, there's a lot of 151.9676. So to finish imputation, what you would do is you would basically copy and paste this and do it again for every single column with a missing value, which in this case is only 3, which is good. But like you'd have to do it for car, building area, year built. I'm not going to do it just because I don't want to make this video longer than it already is. But yeah, imputation is kind of long, especially if a lot of columns have missing values, because basically you just go in and just change every time you see building area, you would change it to, you know, the next one, like cars, if you're replacing the cars one. I'm going to go into this whole thing and explain why it works. And trust me, I know most of you are probably clicking off the video already, but it is helpful because especially this function right here, which is very helpful, and it shows up a ton. Like this comes up a lot in homeworks and stuff. So understanding what which is pretty helpful. So to break this down part by part, we're going to let's start from the inside of this. I'm going to look at the left part first, and let's look at the inside. So the first thing we have is is.na of our column, and I'm actually going to just copy and paste this down here. If we run this, you'll see, and I just realized they are all false because I actually replaced them all. So what I'm going to do, and this is why it's good to make copies, if I go back up here and run it, you'll see it'll rewrite over what I just did, and now the NAs are back. So if I run the is.na, you'll see it's basically a bunch of trues and falses. You know, we've seen this before. Now actually I'm going to switch this over to be our test data set just so our console isn't flooded every time, because there's going to be a lot of numbers being printed down here. But if we go to our test data set and run it, let's look at the C column. You see that's false, true, false, false, true, which lines up with false, true. It goes false, true, false, false, true. That's what it's lining up with. So we're not going to just do is.na of test, which would return us this. And that's because we're looking at just specifically one column and the values in that one column. When you're doing imputation like this, you want the $ and select the column. Now around the is.na we have the which function. Now which is a very, very useful function that comes up a lot. What it does is it takes some sort of condition on the inside. So I'm going to get rid of this for a second. It takes some sort of condition. You put any sort of condition on here, and for every row where this condition is true, which will return that row number or that place value. So what is a condition? A condition is just anything that can be true or false. For instance, I could go in here and let's look at our test asset real quick. Let's say I want to figure out which rows in the B column have, you know, a number greater than 9. Yeah, let's say which rows here have a number in it greater than 9. So I could go which test $B is greater than 9, and if I run this, you'll see it returns 1 and 5. And if we go back to test, you'll see, so rows 1, that's a 10, and row 5, that's 13. So that's how which works. And basically, if you actually run this on the inside, you'll see what it gives is trues and falses and an NA, because there's still an NA in that data set. A condition is anything that gives back trues and falses. And we already know is.na, which I ran up here, gives back trues and falses. It is a condition. So when I say which is.na, I'm saying which row number has an NA. And if I run this, you'll see it gives back 2 and 5. And if we go to test, you'll see rows 2 and 5 have the NAs. So now I want to select each of those rows. I want to grab each of those positions so that I can change them to grab a subset of our data, such as the subset where all the values are NA. So if I do the name of the data set, and then I'm going to do $C because we're looking at the C column, and I don't actually have to do this. What you could do is basically like up here, what I could do is I could get rid of this $building area. I could get rid of the $building area and put a comma and then whatever number building area is. Now the thing is, I wouldn't recommend doing this because also, especially in the building area case, like in our test case, we only have 3. Like we can obviously tell C is 3. But you come to the house data set, you see with building area, you'd kind of have to come in here and you could go, okay, 1, 2, 3, 4 and count them, which is really annoying and takes too long. Or you can technically hover over it and you see it says column 15. So you'd know it is 15. But I generally just recommend doing this in general, but whatever way you want, that's how it works. So I'm going to grab the C column because that's the one we're looking at right now. And I'm going to do square brackets, because square brackets are how we select subsets. And then square brackets, what they want are row numbers. And if you need a refresher on this, I should have posted a video on this already, and maybe there'll be a little card thing popping up now, I don't know. But I should have a video about subsetting at this point. If you've seen that, you might be like, wait, Den, don't square brackets need a row and a column? Well, you see, test $C, this does not have rows and columns. It is just one long row, basically. It's just one vector of values. You only need the row numbers in here, basically, or the position numbers, you know. As in, if I put in 2 and 5 here, that relates to the second number and the fifth number. So how do I get that in here? Well, I could just copy and paste this directly in. And you see, if I run this, that gives me back NA and A, because I just picked the second and the fifth numbers. So I just got the NAs from it. Now, if this is really long, and I did it all in one line, but what you could do is, again, in the subsetting video, if you've seen that, what you could do is break it down part by part. Like you could do like rows equals this, and you see now the word rows is equal to numbers 2 and 5. So when I come in here, I could just do test C rows, and you see that gives me back both the NAs still. Because when you name things, R sees the word rows as this now, and it sees this as 2 and 5. So now it sees rows as 2 and 5. So it's the same thing. So this, some people like doing this. I usually do things in one line just because I like to be efficient, but that means it can get kind of messy like this. So this is how you can do it if you want to break it apart. But now that we have the rows selected, I'm just going to keep this in here now. We can set them equal to whatever we want. And I'm just going to do the mean again. So we can do mean test $C, because we're wanting to take the mean of our column. And again, this will give an NA if we run it. So we need to remember to put NA.rm for NA remove. That's what the RM stands for. True. We want to set it equal to true. And now if we run this, without it, you see that gives us 7.6 repeating. And if we run the whole thing, now if we go back to our test data set, all the NAs are replaced with 7.6 repeating. That's how imputation works. It's kind of long, but it's worth knowing. Now, one last note before I go. What if the column with the missing values is like a word? If I go back to house data set, like let's say one of the types was missing, and it looks like the types are either H, U, or T. There might be other ones down here, but I'm not sure. Wait, I can actually count them. Like, let's see. And this is a function called table. You'll probably see this in another video. Basically what table does is you just put in some column and it counts how many things are in each group. From the table tells us that there's 3 things, H, T, and U, and like here's the numbers for each of them. It looks like H is by far the most. Well, let's say that, you know, we had some NAs in this one. How would we replace them? You can't really take the mean of a word column. Like, that's not going to work. You know, I mean, you could try. Like, we could do house $, type, but you see it's not numeric or logical. Logical is like true or false. Numeric just means it's a number. So yeah, it's just not going to work out for you. Well, how do we replace the NAs then? Well, with words, you just pick whatever is the most common one. So like in this case, if we had, let's say that I mean, it doesn't really matter. Let's say that row 7, let's say this one was missing. We would just replace it with H, because H shows up the most. What if 9 was missing? Well, we'd replace it with H. It doesn't matter that it's actually a U. And that's the problem with imputation, is because, like, what if this was missing? Well, we know it's actually a U, but somehow, you know, that didn't get recorded, and we put it as an H. Well, that can kind of mess up some of our analysis. And that's the annoying thing with imputation, but sometimes imputation's the best you can do. Just when there's missing values are never good. Like, the thing is, omission and imputation are both bad, as in we would prefer not to do them. But missing values do show up. One thing I do recommend, and this is just a general tip, it's not really something I can teach, but try to figure out why the NAs are there. Like in this house data set, you can look and see the NAs are mostly in these 2 columns, and you see most of the time they're in pairs. The building area and the year it's built, for some reason those are both NA a lot. There's probably some reason for that, and if you can figure out what that is, that can be helpful in deciding what to do about them. But yeah, I think that's all I have. I think this video went a little longer than I meant for it to. But yeah, if you have any questions about NAs, how to deal with them, or just anything NA related, you can leave that in the comments. If you have other questions about other statistics related things that I have not made videos on, or you want me to go more in detail to, leave those in the comments too, and I will get to them when I can. Yeah, hopefully you found this helpful.